using the Composite Flat toolset. The topics covered include the piece creation workflow, offset layers, split lines, splitting meshes, the Composite Flat remeshing algorithms, the pre-flattening algorithms, assigning material properties, and optimizing fit. The session today is led by Composite Flat software engineer Luke Naranski.
Today we will be talking about how to prepare patterns with offsets, splits, and plies. We'll begin with the same model we used last time. So last time we talked primarily about the flattening capabilities of Composite Flat. So we were looking at the patterning tab. And just a quick recap, in order to flatten this object, we start with a mesh. We always recommend that we use one of Composite Flat's remeshers. So these are actually in the meshing tab. So we're going to switch back here and we're going to use the Adaptive Remesher. And what this does is it scans the topology of the mesh and it creates a new mesh over top of the original. So we're going to go ahead and click Start, and we can see that very quickly we end up with a new mesh. If we need more fidelity, if we need more detail around the boundary or even the surface, then we can adjust the desired surface tolerance, desired boundary tolerance, and even the minimum edge length. The smaller these numbers, the more triangles and vertices we're going to have. So for this, I'm going to reduce both these to 1. We'll click Start again, and we can see that we're starting to get a bit more detail. Still not quite enough, so we're going to try 0.5. We'll click Start again, and we can see our estimated vertex count is increasing. So we will try 0.1 and 0.1, and now we're at about 550 vertices, and we can see we've got excellent fidelity all the way along the boundary. So we're going to go ahead and click OK. We're going to move back to our patterning tab, and this is where we're going to start the flattening. So to do the standard workflow, we're first going to use the first icon here. We're going to flatten the pieces. And very quickly we end up with an unoptimized flat pattern. We can see from the strain analysis here that we have about 20% strain around the perimeter, and this is indicating that the pattern is way too small. So this is the result of one of Composite Flat's first pre-flatteners. We've got additional pre-flatteners here, starting with our fracture and smart fracture. We have least square conformal map, pelt, lax curvature, our CCM, and our press. So we usually recommend smart fracture is a very, very good choice. It tends to produce very good results. So does pelt, and so does LCSM for symmetrical pieces. So we're first going to use one of our pre-flatteners. This is going to give us a new initial unoptimized flat pattern. In this case, we've greatly reduced all the strain. We've actually introduced a bit of sag. And now, to get our production quality pattern, we're going to use the optimizer. So that is the spring icon. Go ahead and select the piece. And for this one, we're going to choose our material. This could be done with a fiberglass material, or it could be a carbon fiber. You can pick any of the materials that come with Exact Flat. We come default with about, Composite Flat. We come default with about 85 different materials. And you can have your own materials measured and analyzed and inserted into Composite Flat. So we choose our material, go ahead and click OK, and the optimizer is going to start running. So this isn't going to take long, about 10 seconds I believe it took last time. So we're going to let this run, and very quickly we're going to end up with our final optimized flat pattern. So as it's optimizing, we can see that the colors are changing. They're progressing from cyan or red. If we started from a very high strained part, we'd start from red, we'd see those changing to cyan. In this case, we're starting from a lot of black excess sag, and we're progressing more towards white and a bit of cyan here. So we're done optimizing now, and just from the strain analysis here, we can see that we've got about between 3 and 5% strain on this piece here. So depending on the material you're working with, if this is a carbon fiber, this would probably not be a good part. You'd probably want to introduce additional plies. Or if this is something like a fiberglass where the fibers have a bit of moldability to them, might be an acceptable part. So depending on the material, depending on the part you're creating with, this is either a good or bad part. So it's up to you. You have the strain analysis to use to judge whether a part is good or not. You also have the average energy density here in the report. This is going to give you a numerical readout of the quality of the pattern. The closer to 0 this is, the less strain there is in the pattern. And we can also judge the quality and accuracy of the pattern based off of the global or the 3D versus 2D pattern perimeter length. So in this case, it's telling us that we've got a 3D perimeter length of about 10,000 or 1,000 linear millimeters, and we've got a discrepancy between the model and the pattern of about 84 or 85 millimeters. Once we're done with our patterning, we can create a DXF. We can add a grain line, or we can create a DXF. So to add a grain line, we use the grain line tool. We just select an edge here that represents our grain edge. And then we can create a DXF using the DXF output tool. And this will write a DXF to your selected location, complete with your pattern information. If you've added an optional seam allowance, that will be on the DXF. Your grain line is going to be on the DXF, and any kind of hardware markings that you've added using additional patterning techniques will also be on the DXF. So we're going to go ahead, we're going to clean our document here. Actually, I'm going to revert this. So this is the same as reopening the part at its last saved state. So we're going to revert this, and now we've got our fender back here. So today we're going to start right at the piece creation tab, and using this tab we can actually create offset layers. So if this were a composite part, we probably wouldn't want to do it as a single layer. We'd probably want to have multiple layers, and each layer would have a different fiber orientation. So we actually, depending on the thickness of the material, it's best to actually offset your pieces, and that's to account for the accumulation of material surface area as you add additional layers. So as you add additional layers, you're going to build up a thickness, and that's actually going to change the surface area of the piece. So it's best to simulate that by offsetting your surface prior to flattening. That way you can actually take advantage of that buildup during the flattening process, and it's going to give you the best results. If your material is very, very thin, or you're not concerned about the change in surface area, you can still just copy this surface here. So if you have 3 layers, you can copy it 3 times, and instead of having additional material accumulation, you're still going to have 3 different copies of the mesh, but that's going to allow you to create your plies in different orientations. So whether you copy your mesh or actually offset it, it's up to you, but offsetting is pretty easy. So we can do that just using this button here, the offset mesh. So we're going to go ahead and select our mesh and press enter to accept our selection, and we can start to see the dialogues here, and we get a bit of a preview. So with this, you can actually zoom in and see where it's going to be created. So depending on whether this is a mold or a tool, you're going to want to make sure you pay attention to the offset direction. So you can actually flip the direction of the offset just by clicking the flip all. So you're going to want to make sure your offset is going in the right direction, otherwise you're going to end up with a pattern that doesn't fit. We can also adjust how much the pattern is being offset. So this is always going to be in model units. So if we look down here, in the Rhino status bar, we're going to see the units. They're always listed down here. So this is telling us that our offset is in 2 millimeters. So for most cases, you're going to want to offset by the thickness of your material. So unless you're working with a really, really thick material, your offset's probably going to be a lot smaller. But for the purpose of this session, we're going to stick to 2 millimeters just so it's very easy to see and identify the different layers. So we'll go ahead and we'll click offset. And now we've got a second layer. We're going to repeat the command. So I'm just going to click our mesh offset again. And we're going to create a third offset here, just so we have 3 different layers. So very quickly, we've been able to create our 3 different offset layers here. Our next step is to split these up into different plies. So our last session, we flattened this as a single piece, and again during our recap, we flattened this as a single piece, and the results, we ended up with a very high strain part right down the center. So for something like a carbon fiber or any other kind of weave material where the fibers themselves are very rigid, probably not the greatest pattern. For something like a fiberglass, or if you're working with a non-composite material such as a cotton, that pattern would be very acceptable. So for this one, we're actually going to split these layers up into different plies. And in order to do this, we're going to use simple curves to act as cutting curves. So the way cutting curves work in Rhino is they are always going to be projected along the construction plane normal onto the mesh, and wherever the curve intersects the mesh, that's where the cut's going to be created. So when we look at this part here, if we zoom out, we can see we have our construction plane down here. And it's kind of, if we were to project curves, they'd be going straight up, and they probably wouldn't be hitting exactly where we'd expect them to go. Up here at the very, very top of the fender, we'd end up with good cuts, but down here, we'd end up with very elongate cuts that would not accurately represent our intention. So what we want to do is we actually want to fit another construction plane, and we're going to try to get it. So if we're looking at the side, we're going to try to get it so our plane, we're looking right at the edge, and it's kind of just right along like that. And the easiest way to do it is just to use the camera as a bit of a guide. So what we're going to do is we're just going to rotate our camera, and we're going to try to get it so we're looking right down at the piece of where we want the construction plane to go. And then from the toolbar, what we can do is we can click this, this one right here, this icon, and this is going to create a new construction plane that's planned to our current view. So when we click this, we can see our construction plane has now moved. And if we rotate the camera around, we can see that it's not quite exactly where we want it, but we've made a bit of progress. So we'll try again here. We'll just go there. And we'll just try it one more time. So you can do it as many times as you need until you get it just right. Depending on the material, it might not be critical to get it absolutely perfect, but for now, we're going to accept this just like that. So we're going to go ahead and we'll start splitting this up. So once you have your construction plane, you can go ahead and start creating your curves. So there are many different ways to do this. I'm going to show you one technique. And for this, what I'm going to do is I'm going to create a bounding box for these surfaces here. And that's going to act as sort of a guide for our cuts. So what I'm going to do is I'm just going to use the bounding box command. We actually don't have this one in the toolbar yet. But what we're going to do is we're going to use our construction plane coordinate system. So it's going to create a construction plane aligned bounding box. And we're going to create this out of curves. So I'll go ahead and press enter. And very quickly we end up with a bounding box created around here. So the first thing we're going to do is we're going to ungroup. We're going to explode. And we're also going to ungroup. So we're going to use the ungroup command to ungroup these curves. This allows us to select and remove the curves that aren't needed. So we'll remove those. We're going to remove these as well. Remove these. And I'm also going to use the cell dupe command to select the duplicate curves here. So each face of the bounding box is going to have a separate curve there, so we always have duplicates. But once we remove them, we have just these curves down here. I'm also going to keep my document a little tidier, and I'm going to create a new layer here called cut. And we'll just change the color to red real quick so we can very easily see them. And I'm going to place my cutting curves onto the cut layer. So the first thing I'm going to do, we're going to select our top curve. I'm going to use the divide command. I'm going to divide this into 3 equal segments. So that's just going to place points along the curve here. And we can see that those points are spaced evenly, so we end up with 3 segments along the curve. I'm going to repeat the process for this one here. I'm going to use the divide command, but for this one, I'm going to place 6 segments. So we've got 6 equal segments along here. And what I'm going to do with this is we're just going to select this top curve, and we're going to copy it from this point, and we're just going to touch every single one of these points, and we're going to create equal division segments along here. And we'll repeat the process for this one. Copy from here to that point, and again to that point. Lastly, what we're going to do is we're going to, we want to split these different layers, some of them so they're perfectly vertical. We want to split another layer so it's perfectly horizontal. And then for the third layer, we're going to split it at a 45-degree angle. So what I'm going to do is I'm going to create a third curve. We're just going to use the line command. And I'm just going to create the curve and drag it out here. So I'm going to hold shift on my keyboard, and that's going to drop the curve so it's perfectly horizontal on the construction plane. Then what I'm going to do is I'm going to select it, and we're just going to use the rotate command. I'm going to rotate it from here as my origin, select my endpoint, and we're just going to rotate it 45 degrees. So very easily that allows me to rotate this curve. And now that it's rotated, we're going to copy this, and we're just going to touch every single point along here again. So this is a very easy way to create a grid that allows you to split your objects vertically, horizontally, and along the bias. The other benefit to this is what we're going to do is we're going to turn off our mesh, and we can actually examine the splitting planes here, or the cutting curves. So what we want to make sure is that we don't have all three layers coming together at a common point. So this allows us to examine where all of these curves or planes are going to intersect. And right here we've got, it's very close. Same thing over here. So if we don't like the way they're going to come together, what we can do is we can simply just move the location. So I'm just going to drag these down until they're in a location where we're not in danger of having all three layers coming together at the same location. So just visually inspecting here, we're looking pretty good. So we're going to go ahead and accept that. We're going to turn back on our mesh layer. And what we're going to do now is we're going to go ahead and start splitting these. So I'll split the innermost layer vertically. So we're just going to select the inner layer here. We're going to select this icon here, the mesh split. And we're going to select our two vertical curves and press enter. And very quickly we've split that mesh into three different layers. So we'll go ahead and select those. We're just going to hide them. Now we can split the inner or the middle layer. So again, we'll select the middle layer. We're going to use the mesh split. And now we'll select our horizontal or vertical or 45-degree curves here. And very quickly it split them for us. So we're going to use the cell last command that selects the last modified geometry. It's just an easy shortcut to select our split meshes, and now we can hide those as well. This leaves only the top one as a remaining mesh, so we will again use the mesh split command. And remember, it's always going to project these curves along the normal of the plane here up against this mesh. So that's how we're doing the splitting here. So even though with my camera rotated like this, even though these curves aren't even touching the mesh, they're still going to be projected along the normal of the construction plane and onto the mesh. So because we created a bounding box and we're using a bounding box aligned to the construction plane as our template for these cutting curves, we're always guaranteed that these are going to completely split the mesh. So we'll go ahead and press enter, and very quickly we've split this. So it's a bit more preparation. This isn't completely necessary for the flattening aspect, but when we start thinking or considering ply books, and we're going to look more at ply books at our third session next week, we really want to be able to differentiate these different plies from one another. So what we're going to do is we're going to, first of all, we're going to bring back all of our different layers here. And now we're going to turn off our cutting curves for now. We're just going to make the fender the default layer. Select our points, we'll get rid of those. Now what we're going to do is we're actually going to change the name and the color of these different layers. So we're going to give them unique names, and we're going to give them unique colors so they stand out and they're very easily differentiated. So we're just going to modify the Rhino object properties over here. We're going to change the name. We're going to have our three different layers, A, B, and C, and then we're going to name each ply 1, 2, 3, and so on. So this piece here, we'll call this A1, and we're going to leave the color at, we'll change the display color to black. This will be A2. We'll change the display color to red. This is going to be A3. So when we, by doing this, when we go to make our ply book, because every single piece is going to be a different color, it's going to be very easy to identify where these pieces are positioned in the mold or on the tool, and it's going to make it a lot easier to actually produce this pattern. So we'll continue on with A5. We'll change this color to cyan, and we'll finish up with A6, and we'll change this color to blue. We'll quickly select those, and we're going to hide them. Now we will repeat the process for the inner layer here. So this is going to be B1, and we'll make sure the color is black. B2, change the color to red. B3, yellow. B4, and you're not limited to the colors that are displayed here. There is additional colors available, so if you wanted another color, you can just select other, and then you have your full color picker here. But for the purpose of this, we're just going to stick with the colors provided to us. 6. B7. So we'll go ahead and we'll select these ones and we'll hide them. And lastly, we'll finish up with our verticals here. So we'll call this C1 and we'll make sure this is black. C2, we'll change this to, we don't want to change layer, we want to change the color, we'll change this to red. And then lastly, C3. And we'll change this to green. So at this point, we have finished the mesh preparation. We've created our different layers and we've split our different layers into plies. So at this point, we can follow the exact same workflow that we followed at our previous session. So we'll go through all those steps again. Just to summarize what we've done here is we started with our single mesh layer, mesh like this. We created our construction plane just by rotating our camera. You don't necessarily have to create the construction plane. Rhino does have various other views, but if none of these views are perfectly aligned the way you need them to be, then creating a construction plane the way we did is a very easy way to get the cuts that you need. So we created a construction plane using this icon. We then created a bounding box, which allowed us to create our cut lines. We manipulated the curves on that grid such that none of the layers were going to intersect at the exact same spot. And then we used the mesh split command, this icon from the toolbar, to split up our mesh to give us the individual plies. Lastly, we manipulated every single ply here. We changed the color of every single ply, and we changed the name of every single ply as well. And this is to make it a lot easier for us to identify which pattern piece is which. Okay, so we'll go back to our mesh here. We're going to use the show command. This is going to allow us to view all the different meshes here. So the only remaining thing we're going to do, I'm just going to maximize the perspective viewport again. The last thing we're going to do here, and this isn't absolutely necessary, but this is a step that's going to make it a lot easier for us to do our documentation, is we're going to once again select all of our meshes for each individual layer. In this case, I've got our A layer here, and we're just going to drag these off. We're going to create some physical separation here. We're going to rotate under. We're going to select our C layer. And again, we're going to just drag this off over here. We're creating physical separations. Now we can very easily, clearly see we've got our A pieces over here, our B pieces over here, and our C pieces over here. So at this point, we can continue on with the standard composite flat workflow. So we're going to move over to our patterning tab. Actually, sorry, we're going to go to our meshing tab. We want to remesh these first, especially because we've created cuts here. We've created a lot of very small triangles that are next to very large triangles. We've got triangles that have high aspect ratio, so edges that are very, very small and edges that are very, very long. And we've got more triangles than we need here to represent a lot of this geometry. So what we're going to do is we're going to create new meshes using the Adaptive Remesher. So we will select all of our pieces here. And we don't have to worry about the colors or the names. The Adaptive Remesher is going to respect all of those. So when we actually look in the piece list, we can see all of our pieces. All the names are all here. So the Adaptive Remesher isn't going to rename any of our pieces. It's not going to destroy the renaming that we've done there. They're all going to be preserved here. So just like last time, we're going to go ahead, we're going to click Start, and we're just going to observe the results that we have here. So in this case, our fidelity has been degraded a little too much. We can see that it's very angular up here on this one. So just like last time, we're going to reduce the parameters here. So just from last time, we're going to go right down to 1 because that's the values we used last time. These parameters here are automatically computed by the bounding box of everything that's been selected. So last time we only selected basically this piece here, computed the bounding box and gave us our desired tolerances. Because we've added physical separation, we've changed the size of the bounding box, but these values are still in model units. So when we look at this 1 unit surface tolerance, this is actually 1 millimeter. So we're allowing a maximum deviation of 1 millimeter from the original mesh to the new mesh. So if we click Start here, we're not going to see a dramatic change in vertex sizes. So just because we've changed or we've created the physical separation between the pieces, we're definitely going to have to reduce these values a lot more. So last time we went about 0.1 and we ended up with good results, but because we've changed the actual geometry, 0.1 isn't necessarily needed here. Again, we're kind of looking at our estimated vertex counts, and these are on a per piece basis. So the most we're seeing here is about 475, and considering the pieces, that's a pretty good vertex count. So we're going to go ahead and click OK. Now we can zoom in and have a look here. So a couple things to note now that we've actually split this up. We'll just zoom in on these pieces here. When we look at these, the way the Adaptive Remesher has worked, it's ensured that we've got basically the identical vertex topology between two pieces all the way along the cuts. So we've got very clean cuts here, and again we're seeing the very nice equilateral triangles, and we're seeing a very gradual change in triangle size. So these are all characteristics that we want. Whereas before, and we'll just click undo and we'll compare the previous result, we can see that we've got very, very large triangles next to very small triangles, and we've got high aspect ratio triangles. So when we compare this, yes, Composite Flat will be able to flatten it, but it's not the best mesh to be flattening. Remeshing is a very, very quick process, and it will take this and turn it into this, which is a much more desirable process. We can see that all the colors have been preserved, and when we click on the pieces too, we can see that all the names have been preserved as well. So at this point, we'll go ahead and flatten. We're going to switch over to the Patterning tab, and we're going to use the first icon here to create our flat patterns. We're just going to rectangle select all our meshes. We'll go ahead and press enter, and very quickly we end up with our initial flat patterns. For this patterning work, we're actually going to leave our 3D view. So we're going to minimize our perspective viewport, and we're going to go straight to our top viewport. We're also going to make the pattern layer the default layer, and we're going to hide the model and the original 3D model, 3D mesh. And now we're looking at our pattern pieces here. So when we're in wireframe mode, we're actually looking at the true colors of the mesh. So these are the colors that we've assigned to the pieces before flattening. If we go to shaded mode, we're actually looking at the strain analysis now. And if we're in shaded mode and we turn on our edge highlight, the edge highlights are represented in the actual colors, so we can get a bit of a combination view, but I personally like to turn the edge highlight off. It makes it a little easier to see the actual strain, and it makes it easier to gauge the quality and accuracy of the pattern. So as with last time, we've got quite a bit of strain on these pieces. So the first thing we're going to do is we're going to use the Smart Fracture tool. So we're just, without doing anything else, we're just going to smart fracture all these pieces, and we can see that very quickly we're removing pretty much all of the strain, and we're introducing just a little bit of sag to these pattern pieces. So it's a very quick process that we're doing to minimize the amount of time that the optimizer is going to have to spend resolving all this strain. So now that we've used the Smart Fracture tool, what we're going to do is we're going to try to very quickly rearrange these pieces. So we know that this piece over here is one of the C pieces, C2. And what we're going to do now is we're going to use the Find tool to find its neighboring pattern pieces. So we're going to click on the binoculars. We're going to set our find offset. This is going to be in millimeters. So we're going to set a find offset of 5 millimeters. And now when we click on the green edges here, it's going to find the neighboring piece for us. So it's going to translate it and rotate it over so we can see exactly where it goes. So now we've got C1, C2, and C3. This is going to be our top piece, A6. We've got A1 down here. And we're just looking for, that's B7, that's going to be up there. B1 is right here. So again, we're going to use our Find tool. We're actually going to change our Find offset. We'll do 20 millimeters just to have a bit more separation, and we'll just very quickly re-separate these over here too. So B2, B3, B4, 5, 6, and 7, and then we'll repeat the process over here with A1, 2, 3, 4, 5, and 6. So very quickly we were able to reorganize our pattern pieces here. The last step is going to be to optimize. We're not going to do that just yet though, because we have multiple plies here. We actually do want to add a grain line, and this is going to change the way the optimizer optimizes these pieces. And when we go ahead and create a DXF, the grain line actually is output with the DXF as well. So it's very important that we have the grain line set. So to do this, we're going to use the grain tool here. So for this one, we wanted our material direction to all run horizontal. So we're just going to choose an edge right on the perimeter that's more or less in the direction that we're aiming for. So we're just going to repeat the process here. So we're selecting an edge. When we select an edge, this dialog appears. We're not applying global target strain to these pieces. Global target strain is a different way that we can intentionally strain the pieces, but we're not interested in that right now. So we're just going to click OK. The reason we get that dialog is because global target strain is tied in with our grain line tool, and the strain is applied in the direction parallel and transverse to the grain line, but we're not interested in that right now. We just want to place a grain line. So we've placed a grain line for all these pieces. We're going to move on to the B pieces now. So again, we'll click the grain line, and I'm just repeating this command by right-clicking my mouse button. So I don't have to click the icon every time. I can just right-click my mouse button, and that repeats the grain line command. We got the wrong edge there, so we're just going to move it, and we'll continue adding it to all these pieces here. And we'll finish up with C. So you don't have to choose an edge. You can choose any triangle edge on the mesh to act as your grain line. You don't have to choose a perimeter edge. Because our cuts are along the perimeter edges though, I'm selecting the perimeter edges just to make it easier. So we've applied our grain line to every single piece. So now that we have our grain lines, we can go ahead and optimize. We're just going to select every single piece here. And we can choose our material. And we'll go ahead and click OK. So as these pieces are optimizing, we can see from the strain analysis that we have much less strain on these pieces because of where we place the cuts. Again, depending on the material and your development practices, this may or may not be acceptable. So because of that, when you start using Composite Flat, you may want to modify the default strain legend. You might want to change the colors so they better represent your design intentions. So for these ones right here, this piece has maybe 3% strain, this is maybe 1%, maybe 2% max over here. So it's kind of, when we're looking at the strain legend, it's giving it an idea that we're definitely below 5% strain. So depending on the tolerances of your material, if you've got much tighter tolerances, you may want to adjust those strain legend values to make it easier to tell. But for this kind of part here, I think these values would be okay, especially if you're working with something like a fiberglass or cotton. For something like any kind of woven fabric like a carbon fiber, this still may not be acceptable. You may still want to make some adjustments to it, whether you split this up into additional plies or add a dart or relief cut. If that's what you do, then you can definitely do that, so long as the last step you take is always going to be coming back to the optimizer. So we're just finishing up with these pieces over here. So the optimizer does take a little bit longer because we have introduced a grain line and because we do have a bit more strain on these pieces here. But by using the Smart Fracture tool, we've greatly reduced how long it takes to optimize these pieces. So as we start looking at the results of the different pieces here, we can see that for this piece here, piece 12, we have an average energy density of about 2 Newton meter, or 0.2 Newton meters, which is very low. And the values, they do fluctuate from piece to piece depending on the cuts, but we've greatly reduced the strain just by adding the cuts here. So when we did this as a single piece, our average energy density was about 2.5 Newton meters, and now we're well below 0.1 Newton meters for all these pieces here. So we're just finishing up on piece 1 here, and we can see that our average engine density is already down to 0.2 Newton meters, and we're just going to finish up and we'll have a look at the results once we're done. So we're done optimizing. So at this point, if depending on your needs, we can rotate these to get a better orientation. So I'm just going to select these pieces here, and we're going to use the rotate command. I'm just going to select a vertex down here, and we're just going to rotate these in so they're more or less vertical. So we've kind of skewed the patterns here, but we can just manually adjust them here. So at this point, we've flattened all our pieces. We've added a grain line. So we're going to go ahead and we're going to create a DXF now. So we're going to click the DXF icon, and this is going to place a DXF on our hard drive. So we're just going to save this. We'll call this vendor.dxf. And now I'll go ahead. I'm going to re-import this DXF into the Rhino document. So I'm just going to drag this back in. We're going to import the file. We can compare the results that we have. Let's go ahead. I'm going to go ahead and, oops, sorry, our cut layer was turned off. So what we're going to do actually is I'm going to save this file because we've got some duplicate layer names here. I'm going to go ahead and save the file, and we'll open up the DXF separately. So we'll save this as Fender. And there we go. We can see that we've got our cut file here. So the important thing that we're looking at is every single piece has a cut line, and it also has a grain line depending on the edge that we selected. So all these pieces, the grain lines are all left to right horizontal. For these pieces over here, the grain lines, they're all at 45-degree angle or on the bias. And for these pieces over here, the grain lines are all perfectly vertical. So at this point, I'm going to go ahead, I'll reload the model, and we'll run through this again a second time. And we'll do the complete workflow right from creating our offset layers and plies again. So we'll go ahead and open up the model. So we'll start off with our fender. The first thing I'm going to do is I'm going to create my offset. So we're going to go to the Piece Creation tab, and we're going to create an offset of this mesh here. We're going to create an offset of 2 millimeters, and we're just going to zoom in and make sure that we're creating the offset in the correct direction. If this was a mold, we might want to flip it. So for this one, we'll flip the direction. We'll create a different offset here. So we'll offset that one, and we'll offset the inner layer again here. So at this point, we're going to go ahead. We want to rotate our pieces here. We want to try and get our construction plane. So if we're looking at the edge of it, we want the construction plane to be more or less at 45 right there. So we're just going to move this down here like this. And we're going to go ahead and click this icon here. It's going to create a new construction plane. So it's a little... That's a little better right there. So we're going to go ahead and use this. So next up, we're going to create a bounding box. We're just going to rectangle select all our pieces. And we're going to use the bounding box command. We're going to make sure that it's aligned to the construction plane and that we're creating curves. And that's very quickly going to create a bounding box for us. Because these creates 6 different curves, 1 for each side of the bounding box, and because they're all grouped together, we're first going to explode them. And now we're going to ungroup them. This allows us to very quickly select the curves we don't need. And now we're going to select the remaining duplicates and delete those. We're just going to create a new cut layer. We're going to place our cutting curves on a separate layer just to make it easier to manage them. We're going to select our curves, place those on the cutting layer. Next, we're going to use the divide command. We're going to divide this into 3 segments. We're going to divide this one into, we'll do 5 segments for this one. And now we can copy our curves to the division points. This is allowing us to very easily, very quickly create a grid that we're going to use to split up our different plies here. We can see that as we move the curves around, we do have our different snaps here. So in this case, we're snapping to the vertices of the mesh. We want to make sure we're snapping to the point. We can also turn off our vertex snap down here if it's interfering with our work. So this allows us to very easily snap to a point. There are other snaps that will interfere as well, such as your intersect snap, center snap, and near. So just make sure it says point when you're trying to snap it onto the point there. Lastly, we're going to create our curve. This is going to be for our bias cut. So we're going to start down here. We're just going to hold shift, snap it so it's perfectly horizontal. And we're just going to rotate this one 45 degrees using this point as our origin. So that is our first reference point. And we're just going to rotate it 45 degrees. We can now copy this curve. We're going to copy from this point to there, to there, there, and there. We're going to turn off our meshes. This allows us to examine where our different plies are all going to intersect. So we can see we're very close to intersecting at the same point over here. So we might want to we'll select our bias curves, and we're just going to manipulate them. I'm going to hold shift so we're translating this perfectly horizontal or vertical, but we don't have to. So long as our curves all intersect the bounding box, there's nothing wrong with that. So we're just going to, I'm actually going to hold Alt on the keyboard just so I'm not snapping to anything, and we'll just move our curves there. So when we look at them now, we're not intersecting at a common point, so our different layers, they're not going to have any kind of gap right through. At this point, we'll bring back our mesh. We'll start with the outermost layer here. We'll split this so it's perfectly vertical. So we're going to use the mesh split command, and we'll select our vertical curves. And we can see we've split it vertically. We'll use the cell last command to select them all, and we're just going to hide them. This is going to expose the middle layer. We're going to again use our mesh split command. We'll select our bias curves, and we'll split those all along 45. Cell last to select the split meshes, and then we can hide them. And lastly, we'll use the mesh split command, and we're going to split these horizontally. And we'll use the show command to bring back all our layers. So now we have all of our different layers. They've all been split up into plies. At this point, we're going to hide our cutting curves, and we can go ahead and rename and change the color of these pieces. So we'll change this one to A1, and we're just going to quickly change the colors here to red. A2, we'll change this to yellow. A3, green. So one tip, if you do select yellow, just be aware that the selection color for Rhino is yellow. So if you change the color of the piece to yellow, it's going to be very difficult to determine whether you selected it or not. So you may want to avoid yellow as a piece color. B1, we'll change this color to red. B2. B3. You can also choose the same color for multiple pattern pieces, so long as your documentation is clear enough onto where the different piece lies. B5, magenta, and then for B6, because red was one of our endpoints, we're not going to use red again. But for this one, I may want to go for a cyan again. Hide those ones, and then we'll change the names and colors of this one. So C1, C2, C3, C4, use black for that one, and C5. So we've changed the name and color of all the pieces, so we're going to quickly introduce some separation here. We'll rotate under, we want to keep the bias in the middle one where it is. So we'll move the inner layer. And now we can go ahead and we can start our adaptive remesher. So we'll select the adaptive remesher. So one of these pieces does have an error here, so two of our C pieces, we've got geometrically degenerate triangles, so we're just going to remove that one. And again, we'll remove the geometrically degenerate triangles. It's very rare that this dialog appears, but it does give you an alert that there is some kind of problem with the mesh. Topologically, geometrically degenerate triangles just mean that you have triangles with a surface area of 0. They are very safe to remove. By removing them, you're not affecting the surface area of the mesh. However, if you do have incompatible orientations or disjoint mesh, this is an indication that the offset did not perform as expected, and you've got some kind of problem with your offset. So you're going to want to have a very good close look at your offset layer to find the problem. Probably what's happened is your offset mesh has started to intersect itself just because of the curvature. So that might be an indication that you might have to back off your offset distance. So do a bit of repair work before you can continue. In this case, we only had geometrically degenerate triangles, which are triangles with a surface area of 0. So there's no harm in removing them. So we're just going to go ahead and remove those here. And once that's done, we can go ahead and use our adaptive remesher. So we'll click start and have a look at the quality of the mesh here. We have lost a bit of the fidelity, so we're going to reduce these parameters down to 1. And we'll go ahead and click start, and we can see that our vertex count is back up to where we would expect it to be. Next, we're going to go to our pattern tab. We're going to quickly flatten these here. We'll go back to our top-down viewport. We're going to hide the model and the reference mesh. We'll go back to shaded, and we're going to go ahead and we're going to use our smart fraction. So very quickly, we'll refracture all these pieces here. We're going to remove as much of the strain and sag as possible. And lastly, we're going to go ahead and optimize, we're going to go ahead and add a grain line to these. So first, we're just going to use our fine tool. We're very quickly, because we're running out of time here, we're going to very quickly rearrange these pieces here. So we've got our B layer down here. And then lastly, we've got our C layer over here. So that goes up there, this goes over here. Okay, so very quickly, I will add a grain line. So again, we're not using our global target strain. So we're just going to accept the changes without turning global target strain on. I'm just using my right mouse button to repeat the last command. In this case, it's the grain line command. This is A should be over here. And now we can go ahead and optimize these. So while these pieces are optimizing, if anyone has any questions, please feel free to let me know. We'll take a few moments to answer some questions while these pieces are optimizing. Okay, so optimization is complete. So at this point, before we create our DXF, I'm just going to rename our cut layer. We're going to call this split. That way we don't have a layer name conflict. And at this point, we'll go ahead and we'll create our DXF. So we're just going to click the DXF button here. This is going to ask us to save our DXF. So we'll call this Fender 2. And I'll go ahead and import this in. So we can see we've got our DXF exactly as the pieces were laid out. Most importantly, we've got for our A layer over here, we've got all our pieces, or the grain line is perfectly horizontal. For our B layer, all the pieces are 45 degree. And for our C layer, all the pieces are at perfectly horizontal.